Alright, so today we're going to be going over right triangle trigonometry, and this is going to be an offshoot of the unit circle stuff that we learned about before. Now I know it looks like a lot of stuff on the board right now, but pay close attention, make sure you pause and rewind as needed, and if you have any questions, please ask. Alright, so going from what we talked about before with the unit circle, what I'm basically going to do, if you remember, the unit circle has a radius of 1, and there's a certain coordinate x and y, and how this x and y is related to this theta, this angle, with the x-axis, is the sine and the cosine function, okay? So y is equal to sine theta, x is equal to cosine theta. That is for the unit circle only. So what we're going to do is now we're going to use it for any right triangle, rather than a right triangle that has a hypotenuse of 1, like on the unit circle. Okay, so I'm going to take this triangle that's on the unit circle, and pull it out, and put it right here. Okay, so this triangle is supposed to represent that triangle right there. So we got y, x, and the hypotenuse is 1. What I'm going to do is make a similar triangle to this one, using angle, angle, angle similarity. If you remember from geometry, if you have all three angles the same for another triangle, they're similar. Now, if triangles are similar, that means that they are proportional to each other. So if you multiply each side by a certain factor, you'll get the exact sizes of that other triangle. In this case, I just used capital X, Y, and Z to be similar to this triangle right here. The hypotenuse is 1 here, so any number is a multiple of 1, so this would be Z times bigger than this, which would mean that this small y would be Z times bigger than the big Y. This small x is Z times bigger than the big X. Okay, so these triangles are similar. This angle and this angle are the same because these two angles are the same. Okay, try to think about that. Makes sense. Okay, so capital Z is equal to Z times 1, and I wrote right here it's equal to the hypotenuse. Okay, Z times 1 is obviously Z, I just kind of wrote that for clarity, but Z, so you multiply this by Z, you get this side. Okay, big Y is equal to big Z times this Y, this small y right here, to get this one. So what I did here is I substituted the Z, because Z is hypotenuse, like we just said, that's that longest side, if you remember from geometry. The longest side of the triangle is a hypotenuse, times small y. Now what I did for small y is, we know small y is equal to sine theta, so I just put sine theta in there. Just substituted that in. And then I did the same thing for x, okay? So big X is equal to small x times that Z factor. Z is the hypotenuse, small x is cosine theta, substituted it in. I got these three equations right here. Alright, from here, y, we're going to call that the opposite side, because it's the opposite of the theta angle that we're looking at. So we're looking at this theta right here. Opposite of it is over here. The opposite side of it is this big Y. So I kind of put an arrow over here. The opposite is equal to the hypotenuse times sine theta. Now where this comes from is right up here. I just moved it, basically. So all I really did for right here is I replaced this big Y with opposite. We're just going to call it opposite from now on. Okay? Now what I'm going to do is I want to solve for sine theta. I want I want to get sine theta by itself on this side of the equation. So what I'm going to do is get rid of this hypotenuse. Okay? Now to get rid of this hypotenuse, well, hopefully you know that you have to divide. So I'm going to divide both sides by the hypotenuse. Okay? Hypotenuse cancels. You're left with opposite over hypotenuse is equal to sine theta. And if you remember from geometry, that's our definition of sine, opposite over hypotenuse. If you remember that whole acronym SOHCAHTOA, that helps you remember all the trig functions. Sine is opposite over hypotenuse. And that's where this comes from. All this stuff that we went over right here, that's basically the proof for sine theta equals opposite over hypotenuse. Now what I want you guys to do now is solve for cosine. Okay? So you should probably pause the video right now and try to solve for cosine theta and see what you get. So pause it right now. Okay, hopefully you paused it. And now you're playing it again. And now let's go over this. So all we're going to basically do is get rid of this hypotenuse. So I'm going to divide both sides by hypotenuse. Hypotenuse cancels. And you're left with adjacent over hypotenuse. Now I didn't really go over what this adjacent means. We talked about how y is opposite of the theta. Well, x is right next to it. A fancy word for next to is adjacent. So this adjacent is replacing this capital X. Okay, hopefully that makes sense. If not, ask me a question in class about this. But theta is right next to this big X right here, so we call that adjacent. Okay, it means next to. Okay, so adjacent over hypotenuse is equal to cosine theta. Okay, and if you look at our mnemonic to remember this, SOHCAHTOA, the ka part right here, cosine is equal to adjacent over hypotenuse. Now we're going to go over tangent in the next video, so don't worry about that right now. This kind of just shows you how to use sine and cosine for any triangle, and it's all based on the unit circle. Okay, if you have any questions, let me know.